Hello everyone, I'm Sidharth Ranjan and this is joint to work with Sumit Agrawal and Raja Krishnan Rajkumar. Today I'm going to talk about interference predicts locality, evidence from an SOV language. My presentation is outlined into various sections. First, I'll introduce the research problem, then support with a brief background, then I'll discuss our experiments and results, then conclude with a brief discussion and future work. So human language system is long known to be constrained by working memory capacity. In order to account for comprehension difficulty due to such memory constraints, several theories and mechanisms of syntactic complexity have been proposed in sentence comprehension literature. Among those, locality and interference are two such accounts that have been attested to drive sentence comprehension. So locality is the claim that the syntactically related words in a syntactic structure needs to be placed as close as possible within a sentence in order to overcome memory pressure. So this has been formulated by the theory of dependency locality theory, which argues that the distance between syntactically related words determine the retrieval difficulty, which in a way explains the comprehension difficulty in the sentence. For example, if this is the word that is dependent on this particular word, then so in order to make sense of this sentence, this word needs to be retrieved at this integration site. However, if there are words that are intervening between these two, then all these words need to be stored in the memory, and that leads to the decay of information, which eventually cause retrieval difficulty, and that later leads to comprehension difficulty in the sentence. However, in addition to locality effects, there has been long body of work that also shows that the anti-locality effects are also quite prevalent in several languages. And therefore, Vasist and Lewis provide a unified explanation in the form of theory of activation decay and retrieval interference. But the cognitive construct behind locality, which is decay, lacks strong empirical support in sentence comprehension literature. Therefore, it's not clear if locality effect that we see. Uh, so, is it that the decay-based mechanism explains those patterns, or there are other mechanisms such as interference that really cater to those observed effects? Therefore, in this work, we ask, are locality and interference two alternative explanations, or do they operate independently? And thus, this serves as the goal for our work, where we tease apart the effects of locality and interference in Hindi, which is a verb-final language and it's rich in case marking and exhibits high degree of word order freedom. So in this work, to meet this objective, we ask, do interference measures significantly predict dependency length in presence of various cognitive controls such as information status and several predictability based measures? And we find that yes, the effects of locality can be explained using more general retrieval interference based effects. And in a way, locality is not only a function of decay, but memory interference too. So I'll discuss a brief background. I'll provide a brief background to support our research question. So first I'll start with similarity-based interference. So the interference is an idea that memory traces in our mind, if they have similar feature attributes, that then they can cause interference, either during encoding stage or retrieval stage or during the storage of those informations in our mind. So if one reads this sentence, the banker that praised the barber climbed the mountain. So if this word has been encoded, now if we are learning a new information, let's say barber, then these two words having similar features, common noun, can now trigger interference when these two words will be retrieved at the verb climbed. The another way in which interference can affect sentence comprehension is something like if we ask participants to memorize a set of words and then ask them to read this sentence, and then the required information will be retrieved at the verb fixed. So here in this case, the target word boat needs to be retrieved at the word fixed. However, table and sync, since they are already there in our memory, now they will interfere with this word and can be a potential words that can retrieve at the verbal side, thereby causing interference. The effects of dependency locality has been also quite attested in sentence comprehension literature. So in this case, object-relative clause structures are in general more difficult to process and comprehend than subject-relative clauses, and they have been duly explained using locality principle. So in this case, the reporter and attack, they are syntactically related words, and since they have three words intervening, and therefore it has longer dependencies to be processed, and that can cause extra memory load as compared to subject clause, where reporter and attacked has just one word intervening, and therefore it's easier to process and comprehend as compared to subject clause. However, the same outcome can also be achieved using interference-based interpretation. So in this case, if reporter and attack needs to be integrated with each other, but there is a word senator which has similar feature attributes as the reporter and therefore can act as a potential confounder, and that can cause a retrieval difficulty. Unlike what you see in subjective clause, where there is no as such word that between reporter and attack that match the properties of the reporter. Therefore, we will have more interference in object-related clause structures than subject-related clause structures, and hence the more comprehension difficulty in ORC than SRC. Since we are dealing with Hindi, so Hindi has a rich case marking system, and therefore people have also investigated the effects of case markers in sentence comprehension. So case markers are well known to differentiate between subject and object NPs by reducing similarity-based interference, and this happens through because the subjects will have a different case marker. Let's say ergative case marker, and object will have an accusative case marker. So now they have different functionality, and therefore that will reduce interference when they both will be retrieved at the verbal side. However, in addition to interference, case marker also has a predictability component. So if subject has an ergative case marker, then it's highly probable that the verb is going to be past perfected. So in Hindi, prediction-based explanation has received a better empirical support as opposed to similarity-based interference. Now, having understood the background and the research question, now we investigate our research problem. And for this, we make use of publicly available Hindi-Urdu Treebank corpus, which is from Newswire domain. And we especially use those sentences which has well-defined subjects and objects in the sentence. And we compute several so we compute semantic similarity metric, and for this so these all words which are preverbal dependents, they will be retrieved at the integration site, which is the main verb. Therefore we simply compute semantic similarity between this pair of preverbal dependent. So let's say if there are four preverbal dependents of this verb, then we compute cosine similarity between the word of these preverbal dependents. So between H1 and H2, what is the cosine similarity between H2 and H3, and between H3 and H4? And then we sum it up over all the constituents in the sentence, and then we simply compute an average, which represents the similarity effect of that particular sentence. So we make use of word vectors that were obtained from pre-trained models for Hindi, and And this cosine metric has been quite effective in modeling interference effect and reading time in several previous studies. So in order to cross-check if this cosine similarity metric is really accounting for similarity-based interference, so we make use of a human judgment rating data set of word similarity in Hindi, and we find that the cosine similarity metric has a Spearman rank correlation of 0.75. So this attests that the metric that we are going to use in our work has a psychological reality with respect to modeling interference effects. And we compute case-based features. So we simply count all the case markers in the sentence, and then we simply divide it by the number of words in the sentence. So if sentence has more case markers, then they may have greater predictability, or they may have a greater interference, depending on how they are being used. Then we also compute same case bigram sequences. So if two preverbal constituents share similar or same or identical case markers, then that may cause potential confusion when they will be derived at the integration site, in this case the verb told or kaha. So we simply count to the number of identical case marker sequence associated with the pairs of adjacent preverbal constituents. Then we compute dependency length, which accounts for locality effect or decay-based explanation or mechanism. So we compute dependency length estimates for each word in the sentence by simply counting the number of intervening words between head and dependent. So in this case, if dark, the word is dependent on the verb hua, then we simply count the number of intervening words, which is 2. So the 2 is the dependency length for the word dark. And we compute total dependency length by summing over all the dependency length of all the words in the sentence, and then we simply compute the average values representing the memory load associated with this sentence. Then we also compute predictability-based measures. So we compute surprisal estimates for each word. So we compute trigram surprisal, which is nothing but negative log probability of target word given two preceding words. So for this, we first train a trigram language model on again a publicly available email corpus of Hindi, and then we test on the HUTB corpus that we are using as a test data. Then we also compute PCFG surprisal, which account for syntactic structures in the sentence. So we first convert our dependency trees in HUTB to constituency trees, and then we train a parser, a Berkeley parser, and then we compute syntactic surprisal using a 5-fold cross validation. So now the sentence level surprisal was calculated by summing all over the words in the sentence, and then we simply computed the on an average the surprisal estimates in the sentence. And finally, we operationalized information structure using givenness information, which can be modulated either using recent invention or a pronoun. So we annotate each of our sentence in the corpus with the givenness information. So subject or object constituents was assigned a given information if any of the content word in these constituents were mentioned in the preceding sentence in the discourse, or head of the constituent was a pronoun. Let's see this through an example. So this is the preceding sentence in the corpus, and this is the target sentence that we are studying. So these underlined words are actually the same. So this word is previously mentioned in the discourse, and therefore this particular phrase, which is a direct object phrase, will be tagged as given. And the subject phrase has a pronoun, and that means this also has its link with the discourse information. So this also will be tagged as given. So this sentence has a given annotation. Now we numerically annotated with some scores. So given new information is given a +1 score, new given information is given a -1 score, and then given new are given a 0 score. So if a sentence has a givenness adherence, then the IS score, the information score, will be +1. So now we study the relationship between dependency length and interference measures. So our dependent variable is every dependency length, and independent variable is various bunch of predictors that we computed. So predictability based measure, discourse measures, and then our metric of interest, which is similarity measures, which is every similarity and case-based features. So we simply predict dependency using all these predictors. So here's our research question. Do interference measures significantly predict dependency length in presence of information status and predictability-based controls? And here is our first result. So this table is a linear regression model predicting average dependency length of the sentence on our entire data set. So this result conducts a broad coverage study. And here all the regression coefficients are significant and in expected direction, except same case bigram. So here the similarity and case density, both these metrics have positive regression coefficient. That means sentences that have longer dependency length, that they tend to have more case markers, and then they also have semantically similar preverbal dependence, and thereby causing more interference in those sentences. Then we also saw that the information status, the regression coefficient comes out to be negative. That means sentences that have longer dependence and they tend to violate the givenness discourse consideration. And then those sentences also has a higher syntactic surprisal. And then we also found, interestingly, that there is a very interaction effect between syntactic surprisal and trigram surprisal. So the regression coefficient comes out to be negative, which suggests that sentences which have a longer dependency length, they also tend to have a higher syntactic surprisal, but then they have more probable word sequences, and maybe a language processor or the language optimizes in this scenario in order to overcome extra memory load due to longer dependency length and complex syntactic constructions. Then we also investigated our research question on varieties of constructions. So we studied non-canonical constructions, which are quite rare in the corpus and in Hindi language, and then conjunctive constructions, which is quite frequent in Hindi language. So these two constructions have been studied in the previous work, and they have shown that the locality effects are quite prevalent in these rare constructions like non-canonical, and anti-locality effects are quite prevalent in conjunctive constructions. So here is our result for non-canonical constructions, so DO-fronted word order, and we found that for DO-fronted word order sentences, only semantic similarity captured by cosine similarity metric is the only significant predictor of dependency length. And we find a similar result for IO-fronted, indirect object-fronted sentences as well. Therefore, this suggests that those rare constructions do have higher dependency length, and those can be explained using greater semantic similarity in the sentence. Then here's the result for conjunctive construction, and here we find a very similar result. So sentences which have a longer dependency length, they tend to have a greater semantic similarity, as well as more case markers and greater syntactic surprise. So here's an illustrating example, and this example is from non-canonical word order. So direct object is fronted, and since this is a rare construction, so this sentence will be more difficult to process and comprehend, and that is also represented in terms of dependency length. So this sentence has a greater dependency length as opposed to the dependency length, average dependency length in the corpus. And this particular sentence also has a greater semantic similarity as compared to on an average the sentences in the corpus. So both these explanations explain, or both these mechanisms explain the difficulty associated with DO-fronted example. So this can also be seen because these words which are highlighted in red, they are the preverbal dependents of the verb kia, and these words are preverbal dependents have similar syntactic properties and therefore cause retrieval difficulty at the verb kia. So just to conclude, dependency length of the sentence was consistently longer when sentences had preverbal dependents that were semantically similar, and then sentences had poor accessibility in terms of greater syntactic surprisal, and then sentences had a greater proportion of case markers, and then sentences that violated givenness ordering. And our results were consistent across linguistic constructions as well. And our results suggest that there is significant association between the effects of locality and interference, with perhaps the effects of locality is being more reducible to more general interference-based phenomena. So as a general takeaway, our work suggests that one can view working memory as a limited capacity system with not a discrete upper bound or a threshold of the item that one can store in the mind, but rather in a more general memory interference constraints. And as a part of future work, we would like to teach apart the effects of distance and interference by studying the nature of intervening materials between head and dependent units. And then we would like to use contextualized word embeddings and embeddings based on point-wise mutual information. And we would also like to test our hypothesis on spoken Hindi data set in order to see if the results from sentence comprehension translate to language production as well. Thank you.